Hello, guys. My name is Desmond, well known as Dish, and I welcome you to my YouTube channel. So, guys, I'll always mention that if you're watching this lesson from one of my platforms, it could be Facebook, Instagram, or Twitter. And again, you might be watching this from TikTok. Guys, just be aware that I've posted a full lesson on this question on my YouTube channel. So currently we are live, but then as soon as we are done with this live lesson, I'll make this lesson available on my YouTube channel. And again, as you can see, today we'll be dealing with electric circuits. So if you wish to access this question paper, just visit my Telegram channel. If you've got a Telegram account, you can just search for solving exam papers. That's where you'll be able to access this question paper. So I post all the question papers for high school, not necessarily for the subjects that I treat, but for almost all the subjects that you can think of which you do in high school. So guys, please do make sure to subscribe and hit that bell notification so that you're notified of our future uploads. So I won't waste any much time. So for now, we'll just start with the business of the day. So this question, it's question 9 of exam paper of November 2015. So this lesson is suitable for grade 10s, grade 11, and grade 12s. And again, if you're upgrading your physical sciences, this lesson is also suitable for you. So, ladies and gentlemen, we are given a question. As you can see, question 9, you're advised to start this question on a new page. Okay, so I'm just quickly going to read through that statement. And again, as usual, we're just going to go through that given a diagram and of course analyze it a bit before we start with the questions. So guys, the statement reads as follows: a battery with an internal resistance of 1 ohms and an unknown EMF is connected in a circuit as shown below. A high resistance voltmeter V is connected across the battery. A1 and A2 represent ammeters of negligible resistance. Okay, so that is the statement that we're given, and we're also given a circuit below. As you can see, I've tried to draw that circuit there. So guys, remember at all times what I draw by hand doesn't necessarily mean that it's drawn to scale, and again, it shouldn't in any way be compared to the circuit given or the diagram given on the question paper. I was just trying to draw it such that it looks almost the same. But regardless of that, a hand-drawn diagram not being to scale, it doesn't necessarily mean that it's not accurate or it won't serve the purpose that it should serve, which is just for ease of reference. Remember, from time to time, you might find that the information that we get as we calculate, I might just write it there instead of having to write it on my screen because I'll be scrolling up and down. So, guys, again, we've got a mini statement there which says, with switch S closed, the current passing through the 8 ohms resistor is 0.5 amperes. Okay, so guys, as I've indicated, let's just quickly try to analyze that circuit. Okay, so let me talk about the battery. Okay, so we've got 2 cells as you can see there. Okay, so ladies and gentlemen, a battery is the combination of 2 or more cells. Okay, so when you've got this long line and a smaller line, just know this is 1 cell. Okay, and combined with a long line and a smaller line, then you know you've got 2 cells. Okay, So the combination of two cells or more, it's what we call a battery. Okay, I hope you understand that part, right? So now, ladies and gentlemen, within a battery, okay, within a battery, you might have an internal resistance. So that means, let's say for instance, the power of each cell was 1.5 volts. 1.5 volts. Now, because we talk of a battery, which is the combination of those two cells, that means we've got 1 plus 1 plus half and a half, which is equals to 3 volts. Okay, so that means the combination of those two cells, which forms a battery, has a 3 volts. Okay, so what it means by internal resistance, which is represented by a small r, in that case, it's 1 ohms. Okay, it could be 0.5, it could be 0.8, whatever number it is. It means the voltage which is going to supply anything connected to that circuit will be less than 3 volts. Why? Because part of that 3 volts will be resisted by that 1 ohms resistor. So the 1 ohm resistor will resist some of the voltage, it will retain some of the voltage within that battery. Okay, so the other thing that I want to talk about is that this 3 volts, it is referred to as the EMF. So the EMF is the total voltage of those two cells. Okay, that is the EMF. So the moment we've got an EMF and again we've got an internal resistance, then we know not all 3 volts will be used by whatever that is connected to that circle. So you might find that maybe only 2.7 volts it will be shared amongst those connections. Okay, so that means what is it, 0.3 volts will be lost as a result of that internal resistance. So that internal resistance, it resists some of the voltage from being used. So only 2.7 will be used. Okay, so guys, I'm just trying to make it as simple as possible just for you to be able to understand. Okay, you don't need to stress that much. This information that I'm providing is just for you to be able to easily understand the circuits. Then at a later stage, when you're fully confident with the circuits, that's when you can be able to try and make sense out of the voltage, current, resistance, and everything. Okay, so now the other thing that I want to talk about, which is not that much important, just know that this long line, it represents the positive side of the battery, the shorter one negative side of the battery, long one positive, shorter one negative. So current flows from positive all the way up to the negative side. Okay, so that means this is the direction of the current. So that means the current will flow from the battery from the positive side all the way up to the negative side. Okay, so guys, the other thing that I want to talk about, it's the voltmeter and the ammeter. So those are the devices. A voltmeter is used to measure the voltage. So in this case, they've connected a voltmeter across the battery. Okay, so we've got voltage, we've got voltmeter. Okay, so you know the word meter, a water meter reading. Okay, you might have heard of a water meter which reads the volume of water passing through a point. Okay, so now in the circuits we've got what we call a voltmeter and ammeter. Okay, So the ammeter reads the current and the voltmeter reads the voltage. Okay, so don't be confused, guys. When you see a circle with a V, just know that this thing is a meter, okay, which reads voltage. When you see a circle with A, this is an ammeter which reads the current. Okay, so that means on this circuit we've got 3 meters. We've got the voltmeter, we've got the ammeter and the ammeter. So now because we've got 2 ammeters, they are now referred to as A1 and A2. So that means A1, which is ammeter 1, it reads the current passing there, okay, and A2, it reads the current passing there, okay. So guys, the other thing that I want you to notice, I'm not sure if you already noticed what I want to talk about, but if you can have a look at this circuit, you will realize that we've got 2 types of connections. Obviously, you know the 2 types of connections. We've got a series connection and a parallel connection, okay. And again, within a parallel connection, we still have another parallel connection. So I just want you to pay attention to this and you'll realize what I mean when I say I've got 2 types of connections, because it might look as if we've got just one type of connection, which is parallel. So I've tried to make to draw that diagram in different colors. So we've got this part which is drawn in black, which represents the external part of the circuit, and from that point and that point there, this is where you've got a parallel connection, okay. So within this parallel connection, you still have a branch there, which is a parallel connection, okay. So that parallel connection is connected in series with that 20 ohms, okay. So remember, guys, at all times when you've got a parallel connection, you can combine it or convert it from parallel to series. You already know the formula to convert a parallel connection and convert it into a series connection. So guys, let me just draw this part. Let me just draw this part and do this and do that. I just want to show you how it looks like when it's being converted. What else have we got? Okay, something there. We've got R, and then we've got A2 there, and it goes like that. Okay, I just want us to concentrate on that portion there. So we've got A1 there. Okay, so now guys, let's just say this is R1, this is R2, this is R3, and this is R4. Okay, so what I'm trying to say is we can convert R1 and R2 into a series connection, because this is a parallel connection. So that means we're going to then have I'll just draw that portion there. So it's going to be this ammeter there and R4 there. So this is R4, then this is R1 plus R2, okay. Then we have R3 there, we've got ammeter 2 there, okay. So this is R3. So guys, I'm just showing you how to convert this branch into a series connection. So this is how it looks. We can now combine these two, because that's what I meant when I said we've got 2 types of connection. So this connection on its own, it's a parallel connection, okay. It's a parallel connection, and within this parallel connection you have a series connection. So that means you can have I'm not sure if that space will be enough. Let me just do it this way. You've got that ammeter 1, and then you've got, this is that R3, this is ammeter 2, and then you've got that. I hope you're able to see, guys. So that means we've got R1 plus R2 plus R, that is R4. Okay, so guys, in this way, it's more like now we've converted not necessarily converted, but we've combined this connection which is in series into one resistance. Okay, so again, if we want to now combine these two, we can just do the same, and it will look something like that, where you've got, let's say, just one series connection. Obviously you will have an ammeter there, then that means it will be R1 plus R2 plus R4 plus R3. So that is combining this parallel connection. So guys, this is not part of answering any question. I'm just trying to indicate to you that when it comes to the circuits, you've got two types of connections, which is series connection and a parallel connection, and you can convert parallel connection into a series connection. So what I was trying to do there was just to convert from parallel to series by showing that we've got a branch within a parallel connection, which is R1 and R2. In that case, it's R8 and R16. It can be combined to form one resistance or one resistor, and then from there you realize that we've got 1, 2, which are now in series because they are along that same wire. So you can still add these two to combine it into one resistor, of which you now realize that you've got that simple parallel connection that you normally you know, that you normally see in grade 10 and 11. So but this is for grade 12, so you're able to see that you can just convert whatever parallel connection that you've got into a, you know, into a series connection, or combine the parallel into a single resistance. So guys, I think with this part I can say I'm done regarding the explanation of what I wanted to explain to you guys. This was not part of answering the questions, it was just to give you a bit of background. I think I'll need to do a special video just doing the circuits, where I'll be comparing a series connection and a parallel connection. So guys, something that I want you to notice, okay, doesn't really matter if it's that circuit, but otherwise let me just refer to that circuit to say wherever we've got a parallel connection, let's say this is a resistor, and again this is a resistor, this is 2 ohms, let's say this is 4 ohms, or let's say 14 ohms. Okay, so guys, you obviously know that you've got current flowing from the positive to the negative side of the battery. So you'll be having a current moving like that, okay, and when it gets to the parallel connection, you will have a portion of the current passing through that side, and again you'll have the other current passing through that side, and when they get there they join and they continue along that wire. Okay, so what I wanted to explain is that if you've got a potential difference, or if you've got a voltmeter connected across the 2 ohms resistor, let's say it's V and the reading is 7 volts. So guys, this V which is 7 volts of 2 ohms, is the same V as connected on that 14 ohms. Okay, very, very much important, guys. If you've got the voltage across the 2 ohms resistor, just know that that same voltage is the same voltage across the 14 ohms resistor. Okay, so that means a V connected across the 2 ohms is the same as V connected across that other resistor. Okay, so that's what I wanted to explain with regards to a voltmeter connected across one of the resistors in parallel. And the other thing that I want to explain is that you can see you've got 2 ohms, you've got 14 ohms which are connected in parallel. When you use that formula to combine these 2 resistors to form one single resistor, okay, just know that the resistance of the combination of these two is smaller than the smallest resistor. So what it means is that if you use that formula for R parallel, which is equals to R obviously of 14, is it 14? It's 14 plus R of, what is this, is 2. The R parallel that you get, the value that you get must be smaller than the smallest resistor of these 2. So if 2 is the smallest, obviously you've got 14 and 2, and 2 is the smallest. So your answer should be smaller than 2. If for some reason you are requested to calculate the combination or the R parallel of these 2 connection and you get a value which is greater than 2, then you know your answer is incorrect. Okay, so that means you must find a value which is less than the smallest resistor. Okay, so guys, I think for now we can straight away answer the questions. Okay, I hope as we answer the questions we'll be able to learn some more. But as I've indicated, I'm going to do a very special lesson where I'll be focusing on these two types of connections. Then from there you should be having a better understanding. So guys, let's see the first question. Okay, I see the first question. They're saying state Ohm's law in words. Okay, state Ohm's law in words. Won't waste time on this one. So what I can advise you is that if you have a definition of your own, you can always state that definition. It could be a definition from a book, definition from from your teacher, definition from your tutor, your mentor, whoever gave you the definition. You can always state that definition. Doesn't necessarily mean that the one that I'm going to state is the one that you should use. Okay, so state Ohm's law in words. So I'll just indicate you, and then from there you can either write it down. I'll also write it down. If you haven't got anything to write, it's fine. You can still write it down when you replay this video, because I'm going to make it available at the end of this lesson. So guys, if you haven't subscribed, please do subscribe so that you don't miss any uploads. Okay, so ladies and gentlemen, Ohm's law in words states as follows. Okay, the potential difference across a conductor, right? The potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. Okay, so guys, there's a condition to this. This is provided that the temperature and all other physical conditions are constant. Okay, so I can just write it down. The potential, don't mind my handwriting, as long as you can hear what I say. The potential difference across a conductor is directly proportional to to the current in the conductor at constant temperature. Okay, and that condition can just write it in brackets to say provided a temperature and all other physical conditions are constant. So guys, remember, these are the wires, right? And you know sometimes the wires may heat. So when we're dealing with circuits, we assume that the temperature of these wires remains the same. There's no heat generated on those wires, okay? And again, we assume that the ammeters and the voltmeters are not having any impact on the circuit. So that means if that ammeter has got a certain amount of resistance, we just ignore it and assume it only measures the current without having to tamper with the current flowing there, or it doesn't have any resistance which resists some of the current to flow, okay? And again, same applies to a voltmeter. That's why in the statement, I'm not sure if it's stated there, but I remember there's somewhere where they said ammeter 1 and ammeter 2 represents ammeters of negligible resistance. So that means those ammeters connected on those wires, they don't have any resistance, okay? So again, there's no heat. So the reason why you might have an internal resistance is because, you know, guys, those cells, sometimes you can even feel the heat, okay? So that heat is as a result of internal resistance, okay? So guys, that was us answering question 9.1, okay? So that's how you state the definition or you state Ohm's law. So now let's move to the second question. So the second question says calculate the reading on ammeter 1, okay? So this question is allocated 4 marks. Obviously, guys, there was no need for us to mark the first question. It's obvious it's allocated 2 marks. So for just stating the Ohm's law in words, you score full marks, okay? So now the question says calculate the reading on ammeter 1. Where's ammeter 1? There, it's ammeter 1. What does ammeter read? Ammeter reads the current, okay? So they don't have to say calculate the current. They just say calculate the reading on ammeter 1. Then you know you've got 2 ammeters. Where's ammeter 1? There's ammeter 1. What does ammeter read? Then it reads current flowing there, okay? So ladies and gentlemen, very much important, okay? You should know